Hi guys, it's Mrs. Millicent. Okay, I'm gonna do a video on a selection sort. Okay, a selection sort runs a little differently. Let me get my window going here. A selection sort runs a little differently than an insertion sort. Okay, so first let's trace through the code a couple times so we can get a feel for what it does, and then we'll shortcut it. Because again, what you're usually asked to find out is how many times a switch was made. I call it a swap, and that occurs down here. Okay. All right, so let me get a piece of paper. I feel like I'm going to need to zoom out, huh? Let me zoom out just a little. Okay, so we're going to start with an array. We're doing an array of, let's see, let's do 9, 8, 7, 6, 5. Okay, it's in reverse order, so we're going to have to put it in ascending order instead of descending order. Okay, can you guys see that? It looks a little bright. Okay, let me try to zoom in just a little. Okay, so what a selection sort does is it takes the first value and it assigns it as the minimum value. And then it goes and checks to see if another one is less than it. And if it is, it becomes the minimum value. And then it checks the next one. If it's less, then it becomes the minimum value. So it keeps going through and finding the minimum value in all of the unsorted numbers, and then it swaps it out with the current index. Okay. So for this one, let's go through. Leave myself a little bit of room here. So let's see. J is 0. It's got to be less than, let me get my index numbers in here. It's got to be less than, the length is 5 minus 1 is 4. So min index is J, so that's 0. And then I have K is J plus 1, so that's 1. That's got to be less than the length, which is 5. Okay, so if, let's do this. Okay, if this is true, we're going to change the minimum index. Okay, so array of 1, so that's 8, is less than array of 0, which is 9, which is true. Okay, that's true. So now min index is going to become k, which is 1. All right, so now we got to come up here. K also will increase. So now array of k, so array of 2 is 7, is less than array of 1, which is 8. That's also true. So now min index is going to become k, which is 2, and k is going to increment up. Array of 3 is 6, right? Is less than array of min index, which is 2. That is also true. So now min index will become k, which is 3, and k will increase up. So array of 4 is 5, and that is less than array of index 3, which is 6. That is also true. So now min index will become 4. K will go up to 5, but then we're done because 5 is not less than 5. Okay, so now we got to do the rest of it. So if j is not equal to min index, so j is 0, j is not equal to min index. That's true. They're not equal. Okay, so that's true. So now we're going to have temp is going to become, move this up a little bit. Temp is going to become array of j, which is 0, which is 9, right? Oh, there it is, 9. And array of j, so array of 0 is going to become array of min index, which is 4. So this is going to become 5, okay? And then array of min index, so then array of 4 will become temp. Okay, so those two swapped. All right, so we can go through it again. So I've done an entire iteration. Okay, so now I'm going to have to go through it again and go up to j equals 1. Okay, let's do one more. So j equals 1. Okay, I'm just going to bring them down. J equals 1. Min index equals j, which is also 1. And k is always j plus 1, so that's 2. Let's see. Array of 2, which is 7, has to be less than array of 1, which is true. So now min index is going to equal k, so min index will equal 2. And then, of course, k will increment up to 3. So array of 3 is 6. That is less than array of min index, which is 2, or index 2, which is 7. That's also true. So now min index will become 3. This will increment up to 4. Okay. So now array of 4, which is now 9, less than, where am I? Array of min index, which is 3, which is 6. That's not true. Okay, so that's false. So I'm done. Okay, I'm not going to be doing that anymore because that's false. Okay, so now I'm going to come down here. Sorry, I'm trying to zoom in, zoom out. Okay, so now if j does not equal min index, so j is 1, does not equal min index, which is 3, and that's true. So now temp is going to equal array of 1, which is 8, right? Okay. Array of 1 will now equal array of min index, which is 3. So this will now equal 6. And then array min index, so array 3 will now equal temp. So this will now equal 8. Okay. So now I've just swapped those two. Okay. And then what's going to happen is this is going to end because it's going to come up and 7, 7 doesn't need to be moved. Okay. So really all this one did was 2 swaps. Okay. So this did 2 swaps total. Okay. Because now I'm left with the array 5, 6, 7, 8, and 9. And that is in ascending order. Okay. So again, just to understand what it's doing. Okay. It's looking at an item. It's trying to find something, the smallest one of the unsorted, and then it swaps it. Okay. So now that we kind of know what it does, let's do some a little faster. Okay, let's just do a couple. All right, let's do 3, 8, 1, 6, 4, 2. Okay, I think these are same ones I did in the other video just to compare. Okay, let me zoom in a little bit. Okay, so what I'm going to do is I'm going to set this as the min, right? And I'm going to look. That's not smaller. That's smaller. Okay. So that's now the new min. But that's not smaller, that's not smaller, and that's not smaller. So now this is the new min, so it's going to swap with my original index. So now I've got 1, 8, 3, 6, 4, 2. So now I had a swap. So now it considers that sorted. So now I'm going to start with this one. This is my initial min, but this is also smaller. So now this is min. Okay. That's not smaller. That's not smaller. This is smaller. So now this is min. So this is the smallest out of the unsorted. So this will swap with the original index. Okay, so now I have 1, 2, 3, 6, 4, 8. Okay, so that was a swap. So that's considered sorted. So this is the min. There's nobody smaller. So he didn't go anywhere. No swaps. He's considered sorted. Okay. Ooh, I always do that. Okay, so now he's the new min, but then 4 is less, so 4 becomes the new min. 8 is not less. Okay, so then these two swap. So 1, 2, 3, 4, 6, 8. Okay, and then this is considered sorted. That's the new min. Nobody's smaller, so there's no swap. Then of course he should be the last spot. Okay, so this only had 3 swaps. All right. So again, if you understand how it works, you can work through it, not having to trace the code. Not that tracing the code is a bad thing. Okay. So this works a little different than the insertion sort. Okay. So just remember as you go through, once your part is sorted, you don't have to worry about it anymore. Okay. But you'll notice that the selection sort has fewer swaps, okay? However, it does have a nested loop, which takes longer to run, okay? So there's advantages and disadvantages to all kinds of sorts. Okay. Oh, let's do another one real quick. I think I did this other one in the other video. Yeah, 9, 2, 3, 1. Okay. We can sort of see that this isn't going to take very long. Okay. So again, we're going to start with the min, and then it comes over and says, "Ooh, that's now the min. That's bigger. Oh, now this one's the min." Okay. So it's going to swap the 1 and the 9. So 1, 2, 3, 9. So I did have a swap. So that's considered sorted. So that's the min, nothing smaller. And then that's considered sorted. That's the min, nothing smaller. That's considered sorted, and that nothing smaller. So this only had one swap. Okay, this was a little faster. Again, I think the selection sort, I can't remember how many it had. I think it had 5 swaps. Okay, so again, a little different concepts. But again, if you understand the concepts, you can figure out how many times numbers swap without actually going through and doing all the code tracing. Not that doing the code tracing is a bad thing. Okay, I hope this was helpful, and I will see you all later.